This lesson is on inequalities and number lines. We are going to look at inequalities and number lines in this PowerPoint. When we're dealing with things called inequalities, there are four symbols that you need to remember, which you've probably seen in the past. Your less than symbol, meaning your alligator is pointing towards the right, or sorry, the left. It means this is less than. So for example, 8 is less than 8.1. This one with the line underneath means less than or equal to. So negative 10 is less than or equal to negative 5. This little alligator symbol means greater than. So 7 is greater than 4.99. And then you have the line underneath means greater than or equal to. For example, 8 is greater than or equal to 8 because it is also equal to each other. Let's do some for practice. Which of the following are true and which are false? Is 5 greater than or equal to 6? Is 10 less than or equal to 10? And is 2.1 less than negative 2.1? Is negative 5 greater than negative 4? The first one is false because 5 is less than 6. This one is true because 10 is less than or equal to 10. This one is false because 2.1 is actually bigger than negative 2.1. Number lines are your friend when it comes to this, and we're going to work on it in a second. And in this case, negative 5 is actually smaller than negative 4, so this is also false. Let's add in a variable, because most often in math you will use the variable x when you're dealing with inequalities. In algebra, an expression can read x is greater than or equal to 4. You should know now that x, therefore, is any number greater than or equal to 4. Can you give some example of what x could be? And remember, x in this case can be any integer or any rational number with decimals. So can you give some examples of what x could be? Some would be 5, a million, a trillion, 100. There are several examples of what x could be. If you were given a number line that looks something like this, how would you draw x is greater than 4 on the number line? Here is where 4 is. And I know that x has to be greater than or equal to it. So by drawing it on my number line, I would add this little arrow that tells me that basically any number from 4 onwards would make x true. But wait, isn't the number 4 included in this inequality? X is greater than or equal to 4 means x can be 4. So not only are we going to start at 4, we are going to put a closed circle on the 4, which will tell everybody in the math world that this 4 is included in the inequality. So by looking at this number line, I know that x can be 4 and or anything greater than that. Here we have x is less than negative 2. First, let's think of any values of x that would make this true. So anything x less than 2. Second, we're going to be able to draw this inequality on a number line. So thinking of any of these values that make x true, if we think of anything like maybe negative 3, negative 4, negative 5, negative 6, those are all less than negative 2. So keeping those numbers in mind, let's try drawing this on a number line. So here's our number line, and here we've indicated it is negative 2. And I've given us some examples as negative 3, negative 4, negative 5, negative 6, so I know that my arrow is going to have to be pointing towards this way. The next thing that we need to ask ourselves is the negative 2 included in this inequality? Here, I don't see a line underneath, so it's not less than or equal to, it's just less than. So because it's not included, we put an open circle as opposed to like a closed one in the last slide, we put an open circle. This tells me and everybody else in the math world that this negative 2 is not included in the inequality. It's everything that's less than negative 2, but not negative 2. I would like you to try some examples by drawing each inequality on a number line. I would like you to remember to check what kind of circle you should use to begin your drawing and shading, meaning is it going to be a closed dot or an open dot? So here are some examples. X is greater than or equal to 1, x is less than 0, x is greater than negative 5, and x is less than negative 3.5. Take a sec and draw these on a number line. Here are the number lines for you to use to start drawing them. For the first one, our 1 is included, so our dot is going to be closed at the 1. And I know that it has to be greater than 1, so my arrow is going to be pointing to the right. In the second one, my 0 is not included, so it's going to be an open dot, and our arrow is less than, so it's going to be pointing towards the left. Notice how my arrow corresponds to the arrow in which my inequality sign is pointing. For x is greater than -5, well, -5 open and arrow going towards the right. And for my last one, it's going to be closed at -3.5 because it's included, and it's going to be facing towards the left. Now, you've seen what it's like to have x greater than or less than one number, but what happens if x is between, say, -4 and 5? This is how you write it. When x is between -4 and 5, it means that x is greater than 4, but less than or equal to 5. So our alligators are both pointing the same way, and they happen to be pointing towards the right, or sorry, the left. Okay, and so in here I'm just letting you guys know what this means. So -4 is less than x, which is less than or equal to 5. Also known as x is between -4 and 5. Don't forget, it's including the 5 because of this line underneath. Can you think of any numbers that would make this inequality true? Well, I can think of a few. I can think of like -3, -2, -1, 0, 0.5, 1.5, 1.75, and 5 even because it's included. Now, keeping those in mind, first, I know that x is going to be between -4 and 5. Next, let's see whether our dot is open or closed. At the -4, it's going to be open because it's not equal to. And at the less than or equal to 5, it's going to be closed because it's including 5. So you're going to have something that looks like this. And you'll notice that in between these, or highlighted, are some of the numbers that I gave you as examples between -4 and 5. So I know that this has to be true. Here's another example. So I have 0 less than x less than 7. Both arrows are pointing towards the left. Seen this before, might mean x is in between. First, I need you to understand what the inequality is telling you. Can you think of any numbers that make this inequality true? 1, 2, 3, 4, 5, 6, not 7, because it's not included. But don't forget your decimals too. Like you could have like 1.5, 2.5, 3.75. Now, can you draw this inequality on a number line? So here's the number line. So I know that it's definitely going to be between 0 and 7. So here's my line from 0 to 7. Now we think about the circles. Is 0 included? No, because there's no equal to symbol. Is your 7 included? No, because there's no equal to symbol. So both of them are going to be open because they are both not included. Here are some for you to do yourself. Draw each inequality on the number line and remember to check and see which circle you are using to begin or end your drawing. So here are 4 examples. And here are their respective number lines. Try it on your own for a second. Pause this video if you have to, and then play it to check your work. In our first equation, or our first inequality, we have -5 is less than or equal to x, which is less than or equal to 4. So in this case, both arrows are pointing towards the left. It looks like x is in between. So we're going to definitely start at -5 and 4. And because we have lines under both of our inequality signs, both the -5 and the 4 are included with closed dots. Over here, x is between 5 and 7, so I know that it's going to be between 5 and 7. Open at 5 because it's not included, but closed at 7 because it is. Next, we have -2.5 is less than x, which is less than 5.5. So we know that it's going to be between at -2.5, which is here, and 5.5 over here. Both dots open because none of these has an equal to symbol. And last but not least, -1 is less than x, which is less than or equal to 1. So I know that x is going to be between -1 and 1. Open at -1 because there's no equal to, and closed at 1 because there is an equal to. Don't forget that you know how to solve for inequalities. You should know how to solve for x in this situation. You would divide both sides by 2, and you get x is greater than 4. And now you can draw it on the number line. you need to also remember the number one cardinal rule of solving inequalities like equations. When you multiply or divide by a negative number at any time when solving for x, you need to flip your inequality sign to whatever the opposite of it is. Some inequalities that I might run into. An equality like this means x is greater than 0 but less than 7. But how can you read an equality that looks like this? X is less than 0, but it's greater than x. What does this mean? How does this even make sense? It's not in between 0 and 7, so how can we say x is less than 0, but it's also greater than x? First, draw 0 is less than x on a number line. This is the same thing as x is less than 0. So here it is. Next, draw the x is greater than 7 on the same number line. So find 7 and draw x is greater than. Open dot on both, right? Because they're both greater than, not equal to. And that's it. That's the answer. It is vital that you read the inequality properly. Do it out loud if you have to, so that you understand what values of x make the inequality true. This will help you draw your number line. And now, you will most likely be working on handouts that deal with inequalities and number lines.